Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. There's a lot of lies on my screen, as you guys have pointed out. TLDR, in the last weeks that I've been away, which I'll talk about in a second, both Photoshop and the Twitch dashboard are radically different. They have had major updates. Photoshop wouldn't even open my overlay files. I don't know why. It said my swap disks are full, which shouldn't matter because it shouldn't be using that much memory anyway, so who the hell knows what that's about. And then the Twitch dashboard was really confusing. So I just said, screw it, I'm late anyway, we're just gonna stream. And I'll figure that out later. It's a small thing. Anyway, yes, thank you for congratulating me on the marriage, which happened about a week and a half ago. See, check that out. What? Yeah, so I am a married man now. That's where I've been the last couple weeks. And those of you who have been lucky enough to have met my wife by now know that I have a lot to be excited about. So it's pretty great. And we're actually going on a trip this weekend to Sweden, to Gothenburg. And we're going to be spending the weekend at a little Christmas thing. Really looking forward to that. And that's why I'm streaming an hour late. Because we had to suddenly prepare. Because someone announced to Twitter that he was streaming today and not to the wife. So, need a little practice on that front. But other than that, everything's been great. By the way, howdy guys in the chat. Daniel Collin, 2, Dark Second, 2 Curbs. Yeah, I should have added her. So then she would have gotten a notification. That would have been smarter. Anyway, about the Xenowing. This is what we're doing today. I have made basically no progress in the last week since the last stream. I did actually, that's not true. I sat down and started working on the renderer some more. Let me pull up one of these. And I don't know if there's actually any visible differences that you guys haven't seen. Maybe there are. Because I don't know if I showed that I had reduced the resolution. I think I had shown this already. But essentially what I was focusing on is, if I bring up the code, so in here I had a function that was doing all the triangle setup. That's still happening. But the difference is now we actually do tiled rendering. And right now it's a really bad implementation because normally you take all the triangles for the Hayward constructor. Oh yeah, blending is somewhat working. I think it's actually kind of broken right now, which I'll get to. So it's a really dumb tiled rendering implementation where instead of binning all the triangles for the draw call first into different bins per tile, I just go, for every triangle, I actually go through all of the screen tiles. And the reason why it's done this way is because it was easier to sort of massage the code to this, and then eventually I'll separate out the binning and everything. But this way I at least get the rasterizer sort of core separated as soon as possible, which is what I wanted. So it goes over all the different screen tiles and then checks if the bounding boxes overlap. And then it also, this is the really dumb part, it copies the back buffer and depth buffer into the rasterizer memory, and then does the last bit of setup and rasterizes stuff, and then copies the stuff back out. So these copies take a long time. The renderer is really slow right now because of it, like painfully slow. But it does still work, and that's the important part. It actually wasn't that big of a job to change this to a tiled renderer, so that's actually pretty cool. In terms of the code itself, the other thing that I did is I was moving everything to fixed point, and I think I've got most of it done. I think there's still some of the blending stuff that's being done in floating point right now due to laziness. And that's just a matter of massaging that as well. There's a couple other things like the tile buffers. I'm actually going to do double buffered, which just makes it so that I can always read and write data every cycle. So it should actually be very very fast to do that in the actual rasterizer itself. And yeah, most of the math here is done in fixed bits, fixed precision, which is nice. A couple things that are bad. I think in here, it's this one. I have actually a 64-bit divide, which is not going to fly. I actually could do that because it doesn't really matter how long the pipeline is for the rasterizer, since it's going to be fully saturated most of the time anyway, so it doesn't really make much difference if there's a bit more latency. But I think I can reorder some terms and make this 32 bits at least, which we'll want to do. But those are the kind of things where it's like, I actually don't know how to do that in Verilog. So I wanted to do some experiments about how that would work. And in order to do that, I wanted to set up, like we talked about last time, I called the last episode DDR3 testing, which is what it says up there still. But really we ended up debugging UART to try and make that path a little bit faster, and failed, which is fine. But the point of that was so that I would be able to take like a different hardware unit and be able to put it on the actual hardware and interact with it, send data to it, and receive data from it really easily. So I wanted to do some tests where I would do that, where I would set up some kind of unit with some local memory that wasn't necessarily the rasterizer yet, but would follow that same kind of convention where you stream some data to it and then write some registers, wait till a status register is done, and then read the data back. That's kind of the pattern that we want to get to. And then I'll be able to test the rasterizer with that setup. I'll be able to test the vector unit with that setup when we do that eventually. Like, all this stuff becomes much more easily testable. But I also want to do that in isolation first, both to get that pipeline set up and kind of figure out how that's going to look, but also to be able to do experiments on a very simplified unit with, for example, trying to do a bunch of integer dividers. So even if I just have a unit that just integer divides all of the items in the buffer by some constant, that's like a very valuable test for a lot of reasons. So that's what I'm working towards. And as I was doing that, I've been doing a lot of thinking and not a lot of coding, so that's where all this is coming from. But as I was getting to think about that, I thought about like, oh, this is actually going to be kind of a lot of work just to even set that up. And I wanted to do that in a simulated environment. So I kind of looked at the simulators that we already had. And I was doing this pattern before where, let's see, in the sim directory, I have a couple of these where I have essentially verilator generated simulators that then have these drivers that load some Rust code and do a bunch of glue. And this glue is really really verbose and not that ideal. And I was thinking, actually, since we have our own RTL, it'd be really cool if I could actually just generate a simulator code similar to what verilator does, but then directly into Rust code, which would make all the binding just automatic and be nice. So I've been playing around with that idea in my head, and I think I actually want to do that eventually. And I would also like to look into getting the Python code actually as a Rust library instead, because I just think it would be so awesome to be able to, like, for example, when working on the rasterizer, but any testable hardware unit, it would be really cool to be able to get like, to just build that one unit as a simulator, and then literally like how I've separated this unit here in code, it'd be cool to just be able to bring that in, or any amount of these simulators in, to the actual code and test that in isolation, which is kind of the goal. And it'd be really cool if I could do that with that same HDL that's just going to spit out Verilog anyway. Yeah, my age is late. No, I'm 27, I think. Yeah, I think. Yeah, I could emulate the DMA by making that threaded. That'd be cool. Yeah, I think I'm 28 in a couple weeks. I think. 91. Yeah, bang on. Thanks, Matt Triangle. Appreciate it. Spent a lot of time with this stuff. But yeah, so I would actually love to be able to have all of this in Rust. That would be pretty cool. And in fact, I mean, the HDL is really basic, so it wouldn't be that different to have it in Rust. But the big problem I keep coming back to is you need a mutable graph with loops. I actually think that I might have solved most of that, except that you end up having to like insert arenas everywhere. I'm not really sure how that's going to look, but eventually I would like to do that. But in the meantime, there's actually, I think, a better way to do this. So one of the, at least my followers on Twitter, I think this person has viewed the streams before. I'm not actually sure. I keep forgetting this person's name. So let me look something up here. That's great, Drew, too. Sorry, someone literally just called me out on Twitter for calling myself Johnny Cash. Anyway, let's see. Dan G, this person here. I asked this person a question. Let me just pull up the question actually. So I was asking this person because they have this project called verilator RS, which I think was actually mentioned in one of the streams at one point, and I never. It was dumb because I didn't take enough of a good enough look at this. I actually started on GitHub, but I didn't really look at it. Anyway, this verilator RS project is essentially verilator bindings for Rust. So all of that glue that I was doing already, this will actually do for us. So instead of doing our own simulator, I think it would make a lot more sense to at least try this. Now I think with verilator, and someone correct me if I'm wrong about this. I think that there's an issue when you want to include multiple top-level modules in like verilator simulators, because I think the verilator simulator code can only support one simulated module for the whole process. I think it has some global state. I would love to be proven wrong about that, but I think that's the case. But the nice thing is, like that would be a problem if I wanted to use this to test like the rasterizer and the vector unit, but then still have everything hooked up with Rust code on the top level. That's why that's an issue. But the worst case is we could get around that by having one top level module that just exposes enough ports for both units, and then we can still do the glue and everything ourselves. So I actually don't think it would be that bad. But this is like the closest thing to my ideal world that we could have right now. So I wanted to give this a shot, and then at least. For setting up some basic tests against some basic hardware units, I think this would be really helpful. So that I would still be writing the HDL in Python in the HDL that we have, or sorry, the RTL in the HDL that I already have in Python, which has a nice syntax that I'm really happy with. But then we'll be able to hook it up to Rust a lot easier. So I think this will solve a lot of problems for us. And if it doesn't do exactly what we want, like I said, I'm still kind of interested in doing a simulator because I think that'd be fun also. But I don't really want to do that with the current HDL code because it already has enough concerns in it and it's Python, so I don't want to refactor it too much. So I would like to experiment moving that over to Rust. So I'm not really keeping up with the chat. Apologize about that. I work at a hardware company called GraphCore. We make machine learning accelerators. And in particular, we build... yeah, that's I don't work at Fuse anymore. It's been a while. I should update that. But yeah, I work on AI supercomputers. Oh, that's cool, Matt Triangle. Oh, I'm aware of what you guys do. That's great. I think even PowerVR was one of the earlier tiled architectures, wasn't it? Of course, that came up a lot in my recent searches for this architecture. So I think what I want to do, I haven't ran verilator in a while. I think I have to do it in this terminal. Verilator bin. Okay, still available at least. Yeah, I can imagine. Mad triangle. Oh, actually, I want to share this. If you guys have heard of Citadel, it's a company that does reverse engineering and micro benchmarking and stuff, and they did a couple series on late NVIDIA architectures, or a couple papers on that, and they just released one about our architecture, and they worked with our company on it, and so it actually has a lot of really good details. So yeah, wasn't Dreamcast Power VR? I think it was. Anyway, let me find this paper because no. Here. Because this is public and has a lot of very detailed information about the architecture of our chip. And I'm really pleased with this because I'm so excited to talk about it. So I won't go into this too much today, but I just really wanted to share this with you guys because it's really awesome. So if you guys are ever curious about what I think we're the largest transistor count on a per reticle die right now. I think we're 25 million or something. 25 billion, I think it was, actually. Graph core, Colossus, it's the GC2. I'm getting off track and excited here, but 23 billion transistors, that's what we're at. That's the current chip that this paper's about. And in particular, if you're curious what I work on, it's actually this. I know I'm just scrolling through this, but it's the interconnect that go between the chips. I don't think I can say much more than that, but that's what I work on. And you can read more in this paper, which is really well done. Yeah, I would say this chapter 4 is the most relevant stuff to the work that I do on a daily basis. So pretty cool. Anyway, check that out if you guys are curious. No, I work in Oslo. The company is based in Bristol, but the rack scale part of the company, where we're building the really large machines, that's in Oslo. And that's where I work. Two curves, what kind of language framework do you need to code directly for the graph core IPUs? We have our own framework called Poplar, which I guess the closest thing to an existing product to that would be CUDA. I think that's fairly accurate. Anyway, so I want to give this a shot. I want to try this verilated thing. And so what I'm going to do, I'm just going to clone it because that makes it easy to try the example. And we're going to give that a shot. Dev projects git clone this guy. No, I didn't go to school for hardware stuff. I'm all self-taught in the last 5 years. Just pure fascination. And that's also why I keep doing things in weird ways, and I keep experimenting with different HDLs and simulators and all that kind of stuff, because I find that really fun. And my impression actually from now working in a hardware company is actually a lot of those flows are also pretty ad hoc, which makes me feel better about getting really experimental about it. So you can find my agent in the FAQ. Not gonna answer that again. Cargo run. Is it cargo? Is it example? I actually haven't ran an example in a long time. Or is it run -- example? Yes, it is -- example, and the example here is called. Well, it just says example. I don't think this is the way you're supposed to do this. But that's okay. That actually makes this easier anyway. So we can cd example, and cargo run there should do it. But yeah, I guess especially with hardware design, a lot of this is really ad hoc, and a lot of it's because like the thing you're designing is going to be really domain specific. So you'll make a lot of software models and spreadsheet models of how things are going to perform or how things might work, and verify that with whatever tools you can, which often is ad hoc software tools. And that's kind of what we've been doing here, mostly just to make this stuff really easy, so that I feel like I'm having more fun iterating on it, because even though FPGAs are absolutely incredible, and it's pretty sick that in like 5-10 minutes time I can build a whole system like this, but that's still 5-10 minutes versus like 5 seconds that I could have this running a lot slower, but enough that I could verify stuff if it were all in software. So kind of leveraging a lot of that software experience to make the workflow more effective. Hey, Okama. Yeah, maybe cargo run example would have worked. Error occurred. This is what I worried about. So I'm actually going to do this again. Is it -v for verbose? Because I want to know exactly what it did. Yeah, it's just -v. And let me do this too as well, actually. Because this is... Okay. Build script build, failed. Main panicked at, failed to find verilator root. Oh. What? Okay, that is empty. I thought that was something I had in my path. Maybe my path just got messed up at some point. Let me mess with this a bit. And verilator is an excellent tool, but I think it does have limitations, and since I'm doing everything else in Rust, like it's kind of annoying. So it's pretty great if I can mixing up VC and MNGW as well. That's bad. That it shouldn't be doing, but yeah. What? This is the MNGW shell. Ugh, I don't like this. Oh, that's so annoying. This is the kind of problems that are just stupid. That I... Like, what a... Ugh. Just let me bitch while I'm remembering how to get to my environment variables. Oh, come on. No, don't search environment on Bing. Windows is a trash fire right now, you guys. Oh, yeah, of course. You're totally right, Dan Collin. If I do rust up show, I'm using the wrong version of rust up, aren't I? Yes, I am. Thank you. That's a good call. Rust up default stable x86-64 PC Windows GNU. Good call. What? Windows with S. There we go. So that will solve that problem. Of course, this won't work again, but at least we'll see that that's verified. That's a good catch, by the way. Thanks for pointing that out. Both that and that it was using the wrong compiler. I would have missed that, I think. But yeah, I thought I had verilator root set up either in my Windows variables or in my bash RC or whatever it is. Ugh. Oh well, this actually should be relatively quick to fix. I just have to remember where that is. Oh, I'm dropping frames like crazy, aren't I now? Sorry about that. Um, yeah, so there's no traces of this in my bash RC or bash profile, so I'm just gonna find where verilator root ends up being. I think that's in IAMSys stuff. Bin. I think it's just if I do verilator root is I think it's in bin here. No. Yeah, it's just in bin, I think. Actually, wouldn't that put this in my path anyway? If it was in bin there? I think it's actually in user bin. No, that's not where it is. Oh, there we go. It's in GW64 bin. And I don't know why that's not being picked up, because I thought that would mean that it was in my path. And set the var. Okay, then we'll do that. Oops, export. Really? Okay, we can try this too, but I think... Yeah? Really? Ugh. Verilator bin is, verilator's there, and in fact I have... Yeah, there's the script for it. Because if I do GW64 bin, there's verilator. Yeah, it could be. We could try something like this if we wanted to. You guys can see where my install stuff is. I hope this is not the issue, but let's give it a shot. Oh, come on. This is stupid. What if it's something stupid like this? That's so frustrating. Yeah, I can try putting it in my Windows path. Let's try it. Yeah, I could do that. I could. Let me do the print line thing. I'll try that first. Let's see. This should not be the difficult part. Yet here we are. Welcome to software. Verilator RS. And I don't know exactly where it searches for this. I'm guessing it's going to be in this verilator crate. Yeah, because it's looking for verilator bin. Here we do. Get-env arg verilator root. So we know it panics. Where does it do that? Failed to find this. Probably this. Okay, it looks in the path. Command is verilator bin get-env. Seems to be verilator that can't see this then, right? Get-env. Okay, so that picks it up. Yeah, that's possible. Well, if that's the case, we can try that. That was it. Oh, man. Okay, that solved that. No, actually. That's not it, actually, because it does still say the same thing. And then these were other jobs. So this also seemed to fail, probably for different reasons. Who wants to start working on a simulator today? I have so little patience for this stuff, especially for a free time project. Let's try that. LS verilator root. There it is. RG, that's one I'm not familiar with. Is that rip grip? That's a path. Yeah, this needs to be this as well. Yeah. So that worked. Wait a minute. Oh, there's another directory there. That's probably it. Let's try that. I'm going to undo this too to try it. Oh, so I want to do that with risc-v. Still didn't work. Then I'll try this again. Okay, that was it. It was a mixture of those two things. Slightly wrong directory, and the fact that I need that Windows extension. That's so stupid. Mad Triangle, I'm a dropout. I spent 9 months studying computer science. Yeah, now we get this crap with like verilated, all these other paths and stuff. Yeah, this is also my least favorite thing to kind of thing to deal with. You know, at some point I built verilator. Maybe maybe I didn't do this right with the root dir. And man, like, what was I doing? Because I had dev project Xenowing, like make test in particular, also runs verilator, and everything there works. And then we have actual problems because there are fields that are missing, but the verilator part itself totally works. What am I doing differently in the make file that I'm missing here? By the way, this is not at all a reflection of this verilated RS crate, I feel like, which I still think is awesome, and I'm super happy he did that stuff. I also found out that it was inspired by some of the shimming work that I was doing on Xenowing, so it should actually be perfect for our use case. But I've had a lot of issues setting up verilator before, and I'm kind of blaming that. I think the verilated H file is not actually generated. I might be wrong about that. So this, since we know that this build, we can actually dig around in the Xenowing directory and find this again. So when I was a bit more patient, I fought with this before. So in sim, if we go to, for example, actually I think it's in here, it's obj-dir, I think is where it gets to. And here, this is where everything gets built to, I think. And there, you can see there's no verilated .h here. That, I think, ends up somewhere else. And I think, let's see, how do I... Yeah, so verilator's here, and these are the flags. So I use this here, verilator flags. So this is just pretty straightforward, actually. And this doesn't even use exe, so this works. All right, top module and everything. And then that will generate a make file in this obj-dir directory, which I think is just the default. I think you could change that, but I think I just kept that as it was to make it easier. So this probably... Yeah, it makes a lot of stuff. But I wanted to find the make file that's in here. Yeah, see here, it finds these VM prefix. That's vxenowing dot whatever the make file is. So vxenowing.mk, this is the make file that this generates. And here, this, oh, it's share verilator. Aha. Let's do that. Let's expose that as my verilator root. Try running it again. NW share verilator. So if I just export this as is and run cargo run -v, then it could make sense if it only found the binary, because I was looking in the bin directory. If it was in the share directory, verilator, then it might have the header. And so now we have bin, include, etc., and include has verilated. Probably where that comes from. Ugh. Close. So close. Loads of warnings, but that shouldn't matter. By the way, this verilator install and build, I built early 2018 or something, so it's quite out of date, I'm sure. This is... Ooh, that's not good. SCDOS Unix FFI. Of course, it's not going to find Unix on Windows. Okay. So this crate might need some love. Yeah, this is clearly not tested on Windows. So what I should actually do... Actually, I can probably fix this. I'm going to try to fix this. Yeah, verilated source vcd.rs. So that's, I mean, it's all in here. All right, this package isn't very large, this verilated rs thing. So why don't we just try doing this? Verilated source to vcd. This Unix FFI OS strext. Is that something we need even? What if we just do that? There's no way you're dumb, Mad Triangle, if you're working at imagination. Yeah, so now we have std FFI OS stir. It doesn't have as bytes, right? Let's see, Rust FFI OS str. It doesn't have as bytes, but it has to stir, which then that might not work. We could do like 2 string lossy and then do as bytes. I'm gonna do that. That's right here. Oh, this seems to be a bit of a weird way to do this, actually. Because we have a path. So what's the best way to get from path to C string? I think it's fine that it converts it to an OS string like that. But if we're gonna go to as bytes directly, then what's the best way to do that? This directly. That's a good question, actually. What is this used for? So it's used in this one place. So I'm going to do us all a favor. because this is private as well. So let's first of all do this. Surely that's not correct. All right, because again we go to as ref, as OSTer, as bytes, which I think is definitely indirect. Let's do 2str. And this we could do rep or error. Maybe. Let's try doing that. I don't think that will work, but I could just do unwrap here, by the way. Which is not the best thing to do if I'm going to submit a pull request on this, but would at least get this working. Oh, path doesn't have 2-star. Oh, yeah, because this path is an as ref. So actually, can I just make a C string? Actually, C string takes anything that you can put into a vec. So does this actually, can I do this? I don't think so. Also, this does just use open, doesn't it? Here, we just CSTR. Yeah, I might as well just make a string here. Because then I think this path to 2-string, I think we can do that actually. If we do path.2string, then that might not be a CSTR, which we want for this. But if we can do maybe that's what we want. Oh yeah, new needs to be a into string unwrap. Maybe that's the right. Plus path. There is an into string for OS string. I don't know if there is for path. Again, let's just do this. path dot to stir dot unwrap, and then we can do new dot unwrap. I'm after the lazy solution first here. Whoop. Really? Path doesn't have 2 str? What? Is that because of the asref thing? I think it is. What did I start with here, by the way? There's C-string new. That's an IO result even. So actually that should be fine there. But yeah, they called asref on it. That's what it was. First of all, we'll do this. And maybe even this works. We'll try that. And then this should be .asref. We'll see what that gives us. I feel so lazy and stupid when I just sit here and blah at this because I just don't care. Right, and now it's because this error is incompatible, so we're just gonna do an unwrap there. And call this good for now. If we can get to the example and get that working, then I want to just kind of play with that and see what it's like to have these bindings like this. Oh, we made progress. That didn't work. Linker error. I only know because it always lists all these things. vtop new delete, not vtop. Okay, first of all, vtop, oh, it's in function. So operator new operator delete. How though? There's no stdlib. Why is that there actually? Because that's probably where all of this stuff is. Who put that there? Hard to bug depths. This might be risc-v doing this actually. NGW32? That seems wrong. Especially... Do I have to add std++ and build RS? That's not too bad, I guess. Where do I do that? Because this just uses the... Yeah, this CC crate. Figure compiler. I need this spelled out for me like I'm an idiot. Risc-v link lib. Oh yeah. CPP link. Oh, people are just like printing this, aren't they? Yeah, they are. Okay, then that's really easy. If we just need to do that. I guess I could do this anywhere. Let's do it here. Nope. I probably did this in the wrong place. I did find that exact thing in somewhere else as well, Daniel Collins. So I think it's not the syntax. It must be how I'm doing this. I found some code where it's building Spider Monkey. It looks like. Is that what I'm... Did I say that right? Something like that. I am also seeing this actually. Whoops, get rid of this because that didn't help. Where's the build new? I'll try the flag next. If this doesn't help. Wasn't this. And I will try what you guys suggested. So, I guess it's CFG. Yeah, it's one of these, isn't it? So we can do... flat. I've done so many of these harder streams where I literally just sit here and fight with command line tools. It's so funny. That's great, Alcama. Come on. Command with args did not execute successfully. Okay, so this got to G++, I just didn't like it. Dash std lib is lib C++. That looks like it should work. So why doesn't it? Oh no, it should just be lib C++, according to this random thing I found on the internet. Std C++. I'll try that next. Oh, you mean just dash L std C++ to link it that way. Try that. It's also, I see std like this. I have done some simulation stuff at work. I don't know if I'd call it an emulator, but done some of that stuff. Yeah, same issue. Did this... Did this get there? I don't think that this worked. Oh, you can see it? Okay. I'll take your word for it. Oh yeah, here it is. Well, oh, did I miss something you put out, Alcama? So I thought I tried yours first, the .flag thing. Did I not? I thought I had that. Yeah, see, there it is. But that didn't do it, unfortunately. I was like, can't link against std or libc std. I could try that as well. Whoops. Oh, come on. Assign on the trace? Not sure what you mean there. This is the command where it fails. It's risc-v invoking GCC, I think. So this is the command it ran. And there's all of these symbols that it couldn't find. And all of these are or at least new and delete, are things I would expect from the C++ standard library. Another operator delete, a bunch of these CRT IOB things. More new and delete. That is one thing I didn't try. I can tell you I saw that in my searches. pp link std lib std c++. One of these will be the right magic voodoo. Yeah, I'm going to try it. cpp set std lib. That seems to be a good idea. Oops, don't need this grep thing here. Okay, this is new. This is different now. I recognize command line option. std lib is lib C++. Okay, so now we know what that does. Ugh. Let's Google that error. Okay, so it's because of lib. I think it's this. So if we try lib C++, maybe this works. No, it did not like that because that's lib C++. So this must be pretty stupid with how it's forming this argument here. Yeah, there's actually been talk about removing dependencies on the platform linkers for the Rust compiler, and I actually think that's a bad idea. Where's that one from, Alkama? Try SCD. It's only if you don't use that in NUSPort and stable. This is my least favorite kind of problem. I think we tried this, but we'll try it. Doesn't like that either. At least it's reacting. Okay, there is actually a SCD here because we have GNU 17. Sure. Ridiculous. So SCD C++ should be what I want here, right? Which I thought I tried. Oh no, that's CPP link SCD lib. Not set, but link. Let's try another strategy. Let's try searching Rust undefined reference to operator new. See if that comes up with anything. That's a good point. This might be the wrong build RS. That's a good point. This is in verilated, which I would expect to have been the one that we need to modify. There's one there. And there is one in the example. But I think this one shouldn't have that. I feel like it should be in this library. So I think we're editing the right one. Yeah, we could do that. And try and find which will be this. Well, it's this actually. I don't think this copies cleanly. We can try it. Yeah, it does. Okay, so if we if we edit this then. So what were we trying to do here? We could do dash std equals lib c++ here. It didn't like that. Okay, so we're making progress. It didn't like that one either. Yeah, we should be able to remove that if we're just doing this ourselves, shouldn't we? That's a good point. That may help. And then we still have that one at the end. that work? No. Then we just have more errors. Multiple definition of WinMain CRT startup, because I guess Russ is supplying these, which is why that's there, I suppose. Cool. Yeah, because that was already there, wasn't it? Yeah, it is. LSTD C++. This is so frustrating. I'm probably setting a bad example, but I'm considering just giving up on this for today. Didn't I try that? Dash std lib equals lib std C++. I didn't like that. Also, I think there is an std lib thing here earlier. Or am I making that up? I think I'm making that up. Yeah, it didn't help either. Yeah, we could just try what that says, but I don't think that will do it. No. Not finding these. Yeah, okay. That wasn't that. Dash L std C++, which is what we have there. Yeah, I can't remove no std lib. Then it complains about a bunch of undefined symbols or multiply defined symbols that the Rust compiler exports. Or the Rust compiled code exports. I hate these kind of streams because I feel embarrassed struggling with this stuff, but at the same time, this is so common in my everyday life as a developer as well. So you're getting a very accurate picture of what it's like to be a programmer. Try to put it last. Which one? Try to put which one last? No std lib. Dash lstd C++. Isn't that what I have here? I could remove the other one and have this one last. Maybe that's what you mean. I'll try that. Nope, that's not it. It's no worse, but it's no better. For that, we need to do it. Dash std C++ 11 or something. Probably else doesn't help. So what if I search GCC undefined reference operator new, and then no std lib. What's the magic combination of that? No, not finding anything there. I hate it too because when I was thinking about doing a simulator in the first place too, like this is exactly the kind of issues that I was trying to avoid. Because again, having everything in Rust also allows us to just ignore the build system or rather abstract it away. Now I agree it is a bit strange to be able to specify both NoSCD and one of these standard libraries, but here we are. Actually, isn't it no startup files that we want? Is that the one? No start files? That's what it is? I mean, mad if that works. Okay, it doesn't. Yeah, now we have a lot more issues. So that was worse. Oh, man. Okay, here's what I'm going to do. We're going to take a break from this. And let's see. Let's talk about what a simulator might look like. So far, my little HDL that I have in Python is really basic. You can describe at most one module because I haven't done any instantiation. Yeah, do that in the meantime, Daniel Collin. I'm pretty sure it will work because the crate was updated in like October. So I would suspect that it's up to date with some version of Rust and some compiler toolchain and everything. And maybe this is one of those things that would just work under the Windows subsystem for Linux or Linux subsystem for Windows. Isn't that what it is? Always forget. Anyway, yeah, it would be good to verify. So my HDL can right now you can specify one module. You can specify several and it will generate code for several. But normally you'd want to break down the project into a hierarchy of modules. But so far, since I don't support instantiation, I'm doing that in System Verilog actually. And I want to support it in the language, but I'll get into like the one problematic case, which is why I haven't done it before and what I'm kind of going to disallow anyway. And this is all in the HDL, but it's kind of motivated by if I did make a simulator, what are the kind of limitations that I want to have in order to make the simulator be a feasible thing to make? Because I actually don't think it's going to be terribly difficult as long as I solve the lifetime issues in Rust as well as the actual compilation step. So anyway, a module is fairly basic. It consists of some input ports, which I'm going to put in here. So now it will always generate a clock and a reset for you in the HDL that I have. It doesn't actually expose those, which is fine for an HDL that's specific to one project. Also, all the registers are the same kind of registers that have the same kind of resets and everything. So a lot of things we're ignoring. But let's say there's an input A and an input B. It really doesn't matter. And then it has a list of outputs as well, which we could call C and D. And then inside this module, when you have inputs, those are sources of a signal. And then the outputs are sinks. And you can create all kinds of stuff. So you could like invert. How did I just forget the symbol for a NOT gate? Are you kidding me? Almost drew a diode. Anyway, you can invert those. You could take like high, which will give you 1, and you can AND those. Use this operation. But anyway, the point is that you sort of compose these sources into new sources. Like that's what you do here. You can concatenate stuff, and then you have, I don't really know how you'd draw this for concatenation. Let's make up an operator that looks like this or something. You can concatenate these, and then you'll get this vector. So here there's now 2 bits, and so the sources have that kind of size. And then eventually, what you'll do is you might take off one of the bits, which we can say is that, and now this has 1 bit. And eventually, you connect these 2 sinks. So you can connect it to this, or you could create a register, which is both a source and a sink. So it has a source here, and you might have this somewhere in the signal path. Connect this to an output. And then you can also, of course, sync stuff here. So we can connect this source to this sink. And a crucial part about the way that this works, since you can only create sources from other sources, is you actually can't create feedback loops. It's impossible to make, or at least purely combinational feedback loops, I should say. It's impossible to create a situation like this, for example. You can't do that. If you had a register, you could do that. So let's have a register here. And then this is in the feedback loop. That's fine. And for a simulator, this is actually kind of important, because when we have a situation like this where there's only feedback loops available that are registered, then we get this really nice model for a simulator where we have sort of the state, which I'll denote as s of t. So t is time. And then s t plus 1, and so on. And we can also have an s t minus 1. And what's important here is that our simulator's whole job is to basically be able to do this, transition from the current state to the next state. Now, if you take a hierarchy of modules, or in this case just one module, and you flatten it out, then the state itself only consists of the one register. So if we call this R, register, it's literally the state of that register. And then this will be the next state of the register. So if we kind of have these sort of lines here, these sort of barriers, then our simulator step, the whole point is to figure out, based on the inputs, so given the current value of R, and given A, and given B, what is the next value of R, and what is the value of C and D? This is our whole goal, is to solve this. And the point is that when you have no feedback loops in this chain, then this is purely deterministic and only needs one evaluation. Because what you can do is you can do essentially depth first search from all of these sources, and that will schedule all of the work statically. And because there's no feedback loops, this is, you'll never like evaluate half of it and then have to reevaluate parts of it. Does that make sense? So then essentially your top level code is basically you set up A and B if they might be different, and then you call a function called .eval, or I was thinking about calling it .proc for propagate. And then that will calculate these outputs here, which again are the next value for the register C and D. And then you would say clock edge or pause edge. A great handwriting again, or mouse writing, pause edge clock. And then that will actually apply the new state to the registers. That's actually all this one does. So this one does propagation of the combinational logic, and then this one does actual ticking of the registers, just like it would in the actual hardware. But it's really key that we're unable to make these sort of feedback loops. And the problem is, as soon as you have instantiation of other modules, then this model that I presented here actually breaks down. So even though within a module we can only create stuff that doesn't have feedback loops, it's actually relatively easy to take another module and instantiate it and do this. And if internally this was wired straight through like this, then we have a problem. Or if there's an inverter here or something like that, then this is a problematic case. So what I'm thinking to do Yeah, it makes everything easier conceptually as well, which is kind of what I'm sort of postulating here, is that you generally don't want to do this. And I think I actually don't know what like verilator would do in this case. But I know this isn't something you'd want to have in a design. You might want to have something where you have some state here goes into the input here, and that comes out and then goes through some more combinational logic here. And then this might even do some processing to that. So here we could see the same module in both cases, but this one's actually perfectly valid. This is the one we do want. So essentially what I'm thinking to do is take a hierarchy of modules like this and flatten it, and either probably before as a separate pass, or during the flattening pass, actually check for these loops. And if there's any of these loops, then we'll have errors. So essentially I have the model that I already have, which already supports modules. If I just add instantiation and then ways to hook all that up, which is pretty much the same rules for hooking up inputs and outputs within a current module, then it should be relatively easy to do this check on a hierarchy of modules, and then the flattening algorithm becomes trivial. And the flattening algorithm, it makes it very easy to schedule work such that this is our simulator flow. So I think just due to the very simple nature of the HDL that we're working with, I think actually this would be really straightforward to do. But again, the problem is the HDL is in Python right now, and it already has a code gen backend that I would like to simplify, but I don't want to refactor it right now because it's in Python. So I would like to experiment getting that back into Rust. And the other advantage of having it in Rust as well is that currently if we have a hardware module, we need to, and like that, let's say that exports some kind of constant even just in the code itself for bit width of some port, for example. Then that actually needs to be in 3 places. It needs to be in, if we have a software model, it needs to be in the Rust code. If we have some driver for it in C++, it's going to be running on the system, or in C, it needs to be there, and it needs to be in the Python code. Whereas if all the simulator stuff was in Rust, we'd actually only have it in 2 places, which is the C code for the driver, and then the Rust code for the actual HDL implementation, which is also the model once it gets compiled. So I don't know. I might be jumping the gun doing a simulator like this, but I think it would actually be quite fun. And with what I'm thinking here, my whole point of this is that it's actually a very simple model, and that should keep it really tractable. See you, Chief Detector. Thanks for hanging out. So I do think I'll give this verilated thing another shot. The verilated RS create another shot. I know that the author, I think he mentioned at one point that he or she, actually don't know, but this person actually mentioned that they were not actually working with Verilog anymore. So I don't know how important it is that would get fixed. But I feel like I should give it another shot anyway. Maybe fight with it later when I'm not on the stream. But I honestly also might just jump in and do this Rust simulator thing because it's fun, and ultimately that's what matters here. Plus, I think that's just like the ultimate workflow is like in this case, I loved taking this rasterizer and slowly separating it out into its own module, and it would be so cool to then just have a parallel module that's just essentially pure Rust code, even if that code is just building a graph structure that is essentially the HDL. It'd be so cool to start developing that also in Rust and just be able to pull it in really naturally, because I imagine that the way that the code gen would work for the simulator is it would just dump Rust code, probably as part of another crate that has some build RS thing. But in the simplest case, I can just have a function that just outputs a .rs file, which can be part of a different build or something. So it should be really then it's like seamless to pull it in, which is the point. And then I can, instead of instantiating this struct, I would instantiate the one that's generated from the HDL. And then what I would basically do is comment out most of this, and then I would have feature parity on both, and then I would uncomment stuff in the software model and then try to implement it in the hardware model and slowly sort of build it back up that way. And I think that would be really fun. And even getting back to where we started of the stream today, I was talking about testing these individual units and having little command processors so that I could put them on the FPGA and send commands over like UART. Developing those command processors as well would be really easy to do like it's a software model in Rust and then slowly move to a hardware model. And again, test that all just in simulation before we move it on to the FPGA. So, yeah, I'm building a GPU and a CPU and a bunch of other stuff. I've been calling it a game console, but I guess SoC is actually more accurate. And I'm trying to simulate like the whole design is really the idea, because FPGA workflow is certainly not the worst, but it could be a lot better. So yeah, I don't know. In my head, if I had all this stuff that was specifically tailored to my Rust workflow, this would be perfect. And I think also this would go beyond this particular project because, like if I want to play with a sound chip design or whatever, like I would really like a good flow to just be able to play with hardware stuff. That's kind of the whole point and why I even let myself do an HDL this last summer, that I'm using this project on as a guinea pig for, if I'm saying that right. If you can't tell, I'm kind of fighting myself on the idea a little bit because there's also a part of my brain that says like, man, if you just tough it out and just write the system Verilog, you'd probably be done by now. But at the same time, I really like asking these questions and I like this angle. So, I don't know. I should just indulge in what I think is fun and not care. But there is a part of my engineer brain that is for and a part that's against this idea. But I think I'll end up doing it because it's fun. And even if all this verilator simulator stuff worked perfectly, it might be like, I know it was annoying to set up verilator on my Windows PC before, so it'd be nice to not have to deal with that. And I know also, again, I think I mentioned, I don't think you can have multiple top level modules from a verilator simulator. So there's a lot of problems that I would avoid. But of course, then we gain a problem of having to maintain a simulator. But I think that would be fun. I think it would be relatively simple. And the other reason I want to bring the HDL into Rust then is it makes it easier, at least for me, to write tests and be able to refactor it if I have to. So I think what I'm getting at is I'm just going to end up doing it. And it's funny now because the state of the repo, it's like half of the RTL is in system Verilog, half of the RTL is in this Python HDL that I might replace with the Rust HDL. So then we would have this period where half the Python stuff is then going to be Rust. The nice part is that because it's module based, we can replace one module at a time, which is what I did with the Python one too. So that's kind of nice. But still, it's going to be a mess. But I mean, it'll all converge eventually. I'm not really embarrassed by having kind of a messy repo now as I'm exploring a lot of ideas, because I'm exploring ideas in the context of a real project. So I can't really complain about having tried a lot of things. But it will be kind of funny. And if it works, I should have a really cool flow, which might be useful to some of the other guys, I can imagine. In particular, Daniel Collin might have a use for that kind of simulator, that kind of environment. Or not. It might just live and die with this project, which I'm also totally okay with. So, yeah, that's cool that you build model GPUs. I didn't know you did that as well, Daniel Collin. I'm just a plebe who does it in my free time. But I guess the main thing I'm getting at though that I'm still missing with verilator is that if I want to play with one of these simple setups and I want to like make throwaway programs for a specific piece of hardware, it's still too much work to do that. Oh, I see what you mean. Yeah. Yeah, it should be better to just do what I want in my free time. If I end up with good stuff, I have no problem putting in extra effort that I normally wouldn't want to do for like documentation and stuff. But that's kind of a different thing, because then I've kind of doubled down on an idea and found that it's good, and then I've decided that it deserves more packaging and stuff. But yeah. And again, I think I mentioned it before, but I have been quite happy with having a custom HDL for this project. I really like the syntax, and I feel like it's made me more productive and more interested in just writing the HDL or writing any RTL. So that's a win in my book. And it's fun. So yeah, I'm going to play with some simulator stuff, and I might have something by the time I do the next stream. Anyway, thanks you guys for hanging out so much. I really appreciate it. I'm gonna head out because it's been 2 hours. I shouldn't have streamed this long today, but here we are. This was fun, even though it didn't really go anywhere, but happy to be able to share these ideas. So yeah. Anyway, thanks guys, and I'll see you next time.